Can someone give me what they would define as a variable? What would be a variable? Can someone give me an example of a variable? How about that? Diana?
Like y.
Okay, so y is an example of a variable. All right. Can anybody else give me another example of a variable? Yeah. X, okay. X is another example of a variable. N. Are we limited to only these letters or what?
How about B?
We can use B. Can we use any letter of the alphabet? Yeah, we can use any letter of the alphabet. Now, what do those letters stand for? Well, if they are a variable, so like when we get to definitions, can we define a word with its own word? Can we say a variable is a variable? No. So, what can we define a variable as? Yeah.
Like short term for a word, basically.
A word, okay. So sometimes it might be a word, but in math, we're gonna use a variable in place of a number. So it's basically, we're talking about a value, okay, or number, okay, and Victor, it changes depending upon the equation or expression. And the fact that it changes makes it a variable. So for example, if I were to, and don't write this part down, okay? If I said 2x equals 6, so 2 times some number is 6, what would x represent? 2 times what is 6?
What number?
What number?
That you don't know yet.
I want a specific number. Can you give me exactly what x is? 2 times what is 6? 3. Okay. But now if I used x again and said 2 times some number is 8, what does x equal?
4.
So before x was 3, now x is 4. So it changed, right? And it changed because the equation changed. So it's a value or a number that changes based upon an expression, okay? That changes based upon the equation. I'll put expression or equation. EXP for expression, EQ for equation. Okay? All right. So what would be an algebraic expression? An example of an algebraic expression is right below. See how it says evaluate the expression when y equals 2 for 6y, 8 divided by y, so on and so forth. Okay? So, what would be an algebraic expression? What's wrong, Victor? What's wrong? No, if you got a question, ask me.
Why is this recording?
Oh, because, great question. So, anytime somebody's absent, they would be able to stay caught up with the notes. So, for example, Anton's not here today, right? I'm going to post this on Schoology. Anton could watch the notes tonight, and then he'll be all caught up. Got it? Does that answer your question? So, if you're sick, okay, email me and say, hey, Miss Kelly, what did I miss today? I'll email you back the notes, the worksheet, and the link. Or I'll say, hey, the link is going to be posted on Schoology, and then you can stay caught up. Sound good? Again, I'm doing this to help you. Otherwise, you come back tomorrow, and now you got double the work. Everything that you missed the day you were sick, and then everything from that day that you got to catch up on. Okay? All right, so an algebraic expression. You got 6y, 8 divided by y plus 4, 11 minus y. What would be an algebraic expression? And, you know, I'm not looking for a formal definition. So you don't have to, like, you know, look it up on Wikipedia. You don't have to look in a book, you know. Just put it in your own words. And the reason why I want you to put it in your own words is because it'll mean more to you than trying to memorize somebody else's terms, okay? So 6y, 8 divided by y, any ideas? Can we use the word operation? If I use the word operation, what does that mean? What does that mean to you? In terms of math, not surgery. Operation would be like adding, subtracting, multiplying, dividing. So on A here what are we doing?
You're gonna multiply.
On B we are, on C we are, on D we are subtracting.
4, 6, 9.
Next, okay, on all of these, are we using a variable?
Yeah.
Yeah. So why don't we just say an operation involving a variable? And that'll be an algebraic expression, okay? So an operation involving a variable, okay? And a lot of times, we want to learn how to simplify. Okay, so we always want to try and simplify algebraic expressions. Okay? All right. So some of you already said what the operations were when we went through this. So, and when we mean evaluate, we want you to come up with an exact value, a number, no more letters. So the goal here is to change the letter to whatever it is equal to. So in our case, y is equal to 2, and then perform the operation. So 6 times 2, you would say is 12. 8 divided by 2, you would say is
4, 6,
2 plus 4, you would say is
6.
and 11 minus 2, you would say is 9. Does that make sense? Okay, so we're performing an operation, okay, with a variable. We're changing the value of that variable to what it is, okay? Alex, you doing okay?
Yeah, Mom.
We don't need the iPad right now, just so you know. Okay? All right. Next, power expressions. Does anybody know like another word for power that maybe they use? So if you look like, you see that 3 with a little 4, what would be like a synonym or another word you're probably used to using?
3 for the 4th power.
3 to the 4th power, okay, and 4 represents an exponent. Okay, so we're using something that involves an exponent. So when we expand 3 to the 4th, okay, what does that mean? What operation are you doing if you were not using the exponent? Let's change it to like adding, subtracting, multiplying, or dividing. What would you say it is?
You're basically doing like 3, like 4 times.
Okay, what are we doing with the 3 4 times? What operation?
Like, let's say if you're multiplying, you do 3 times 3 times 3 times 3.
So she says this is 3 times 3 times 3 times 3. Brian, what were you going to say? Same thing? Same thing? Okay, that is correct. All right, so when they say expand, expand means use your operation and multiply it out. Now, could we have done 3 plus 3 plus 3 plus 3 to be 3 to the 4th? No, it has to be multiplying, okay? All right? So now, if I were to put that into words, how would you describe 3 to the 4th? What would you say? So here, when I say put into words, all right, put it into this, and this is the way like a lot of the things that I do is imagine you are teaching your little brother or sister what 3 to the 4th is. How would you explain to them what 3 to the 4th is? What words would you use? What would you say?
3 to the 4th power.
Okay, but now like, you know, my little sister Maureen says, well, what does that mean? What does 3 to the 4th power mean?
It means like 3 to like 4th power of the sun, or
Okay,
just times it by how many days?
times what?
You just do 3 times itself, the number and it's perfect.
Okay, so in terms of our case, like the 3 to the 4th power, we would take 3 and we would multiply by itself 4 times. Okay, so like you said, the exponent tells us how many times that we're going to multiply. The 3, the base, okay, is the number that we use to multiply by itself. Okay, that number of times. All right. Special exponents. Okay, if I ever, use a 2 as an exponent, sometimes someone might use a different word for it. So for example, let's say I had 4 to the power of 2, or 4 to the second, or someone might use a specific word. They might say 4, I'll give you a hint, begins with an S. Has a letter that we rarely use, Q, S-Q, squared. All right, so this is the same thing as 4 squared, okay? So anytime you hear that word squared, what you're supposed to know, okay, is that means 4 to the second power, okay? All right, so what if I did 4 to the power of 3? Say it louder. All right, so it would be 4 cubed, okay? All right, usually there's not another word for when you get to 4 to the 4th and so on and so forth, okay? All right, so understand what those things are, okay? Question? We're good? Okay, so coming down here, all right? So when the power, write the power in words, and then we're going to write it again as a product. So when they write it in words, okay, and this is to get us used to, written expressions, okay, what I want you to write is 9 to the 5th power. And then as a product, I want you to write 9 times 9 times 9 times 9 times 9. And earlier, we said, okay, Alex helped us out, that we would take the 9 and we would multiply it by itself 5 times. Those were the words that we used. And so now all you're going to do is you're going to show that, okay? All right, see if you can do the other 2 on your own. Marisol, B, what did you write?
5 squared.
All right, so she wrote 5 squared. She used the idea from up here. Did anybody not use 5 squared? All right, what'd you write? 5 to the second and D power. All right. Brian, what did you write in terms of a product? 5 times 5. Okay. All right. Third one. Let's go, Maria.
N cubed.
Okay, she wrote n cubed. Anybody not use the cubed and use something else? All right, what'd you do? Say it again. N to the third power. And Ron, how did you write that? N times n times n. Okay? Questions? All right, flip it over, page 2. All right, so the reason why we did that was to help us with our evaluating. Some people kind of struggle with the exponents, and so if you at least understand what, x cubed means, then maybe you can put it in the form of a product and do it that way. So, for example, x cubed, if I evaluate using x is equal to 8, that's the same thing as 8 cubed. According to what we wrote on the front, that's the same thing as 8 times 8 times 8. Okay, so whatever way you need in order to evaluate this, okay, we need to be able to come up with one number. So let's start with the first two. What's 8 times 8? 64. What's 64 times 8? Do you know how to do that mentally? Nobody? Nobody? Nobody's able to come up with 512? Yeah? Without using a calculator? How'd you do that mentally?
I wrote it out.
Oh, okay. So one of the things you can do is write it out. Or if I had to do 8 times 64, do any of you ever think about doing 8 times 60
No.
plus 8 times 4, using something that we're going to learn later on in this chapter, the distributive property? So like 480 plus 32, and then 480 plus 32 is 512. Just, you know, looking ahead a little bit, okay? All right, see if you can do B and C. Evaluate. When we say evaluate, remember, we want to come up with one number. Here, Akush, what did you get for B? 62.5?
Yeah.
All right, so he's got a 62.5. And how did you do that?
I multiplied
What did you multiply?
2.5 times 2.5.
All right, so you did 2.5 times 2.5, and the reason is, remember that you have a 2.5 squared. Now, reminder on this, okay? When you're multiplying and you've got 2 decimal places, shouldn't your answer have 2 decimal places? So shouldn't we change our answer from 62.5 to 6.25? Okay? All right, D. Crossy, what'd you get for D?
0.06.
0.0, what'd you get?
2?
2? Did you round?
Yeah, rounded up.
All right, so here's a general rule of thumb, and it's good that it came up, is if your question is given to you in fraction form, usually you give your answer in fraction form. So if they gave it to us as a fraction at the beginning, I want a fraction at the end. So was anybody able to come up with a fraction as the answer? What did you get
For one.
for the last one, C?
I haven't done it.
You haven't done it, why not?
Oh, it's 1 and 1/3.
1 and 1/3? Okay, so can you explain to him how you did that? So let's start with the evaluating. The evaluating simply means that we are going to change the letter to its actual value. So what does D equal? Just look at the question. What does D equal?
1/3.
1/3 to the 4th power. Now, what does that mean? Hopefully you're all saying 1/3 times 1/3 times 1/3 times 1/3, right? All right, so walking around and looking at certain people's papers, I saw people do 1 times 1 times 1 times 1 is 4. Would you agree with that?
No.
Why? What's 1 times 1? 1 times 1 again is? Times 1 again is 1. Okay. So that's how we're getting answers of like 4/3. Okay, because you're adding the 4 ones together and getting 4 instead of multiplying. All right, so now, what's 3 times 3? 9. Not add, 9. What's 9 times 3? 27. Here's the tricky one. What's 27 times 3? 81. There you go. So it's 1 over 81 is our final answer, okay? Use that instead of the 0.02, okay? Got it?
Yes.
All right, sounds like we're struggling a little bit, so we're not done yet then, okay? D, putting this in the form of a word problem. Each edge of a storage cube is 14 inches long. Find the volume of the storage cube if volume is found by doing S cubed. All right, so we got 2 letters there. What does V stand for? What does the S stand for? Nope. Anybody else? Each edge of a storage cube is 14 inches long. Okay? If you need to, one of the big things that I will talk about all year is the idea of drawing a picture. So, cube. What does a cube look like? Would you agree that this kind of looks like a cube?
Yes.
All right. So it's saying that each edge is 14 inches. So 14 inches, 14 inches, and 14 inches. What would be another word for this line? Give me anything. You can either give me the base would actually, all right, if we talked about the base of the square, okay, good. Anybody else? I'll give you a hint. One of the words is actually in the sentence. Daisy, any ideas? Edge. Okay, so each edge. Okay, if this was a square, you would call each of these what? I'm looking a length or something that begins with an S. How about can you give me something length? Blank length. Begins with an S. Side length. Okay, so the S here stands for our side length, and each side length is equal to 14 inches. So I am going to plug the 14 in here, and I am going to say that V, the volume, is equal to 14 cubed. See if you can come up with a final answer. Go. We're going to do 14 times 14 times 14, and we're going to get 2,744. Okay, and then does anybody know how to write the units? Since it's a word problem, we should get what units?
I don't know.
Well, look at the question. What inches? Squared?
No.
Cubed. Because since we're using cubed, we're going to stick with cubed, okay? And so that's our final answer, okay? All right, so quick little review. When we are evaluating, okay, first thing that we're going to do is we're going to change the letter to what it actually equals. So we're going to change our S to a 14. We're going to change our, D's to whatever they equal, our K's, our M's. And then after that, it comes down to evaluating. If you're having trouble with the exponents, remember, rewrite it as a product like you see here, and then do it from there, okay? Questions?
No.
You sure?